All right, so this is our last lesson of the unit, so let's try to knock it out. It is on the graphs of these things, okay? So today we're graphing exponential functions, and then we're graphing logarithmic functions, and we're going to keep it super basic because there's no point in making it complicated. So here we go. So this is going to be the parent function. All right, so an exponential function has a horizontal asymptote on the x-axis at y equals 0. Okay. Now the parent function goes through the point 0, 1. Excuse me. Goes through the point 0, 1. And then it runs along this asymptote, goes up through it. Okay. There's the parent function. Now, technically, the steepness of this curve here depends on the base of the exponential. We don't really care graphing these things. Just make it look something like this and we'll call it good, okay? But here's the important stuff. You're always going to be moving around and stretching or whatever the horizontal asymptote. So there's a horizontal asymptote at y equals 0. Okay. And it's always, 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 unless it moves around, going to go through the point 0, 1. All right? Now, what do you think is going to happen? So let's say, an example of this would be like y equals 2 to the x. Okay? What do you think is going to happen if we have a fractional base? Well, we get a fraction by raising a base to a negative power. Okay, so that means that 1/2 to the x is the same thing as 2 to the negative x, right? We've seen this, that if you have a negative exponent, that flips the base. Okay, and remember, when we're graphing, if there is a negative up here, that is going to be a y flip. Okay? So basically, instead of looking like this up here, it's going to look like this. Okay? We call that exponential decay because it's getting smaller. All right? All right, moving forward. So let's look at some examples of this. So if I have f of x equals 2 to the x minus 3. Okay, that x minus 3 is going to make us move to the right 3. All right, so we're going to the right 3. And then that's it. So let's think about this. For our horizontal asymptote, if I move to the right on a horizontal asymptote, is that going to do anything? Well, if it's already moving infinitely to the left and to the right, that's not going to change that horizontal asymptote at all. Okay? Now, the point at 0, 1, right here, so it's normally right here, will move to the right to 0, 3. So, our graph looks like this. Ooh, let's try that again. So it's going to run along this, go up through that, and that's when it takes its turn up. Okay, once you hit that point that you marked, that's when it's going to start going up, like really fast. Okay? All right. Let's look at example number 2. So here I've got 1/3 to the x plus 2 minus 5. Okay. So that 1/2 as my, or 1/3, I'm sorry, as my base means that I will be going downward instead of going upward. Okay, so this one's going to look like this because of that 1/3. All right, now we're also going to go right to I'm sorry, that's wrong. We're going to go left 2, and we're going to go down 5. okay? So let's look at that. Now, we've already looked at the fact that the left 2 parts not going to affect our horizontal asymptote. However, that down 5 will, okay? That horizontal asymptote has moved down 5 spaces, okay? Now, the point that's normally at 0, 1 needs to move to the left 2 spots, so that's going to go to -2, and then down 5. So our point should be at -2, -4. Because that's to the left 1, 2, and down 1, 2, 3, 4, 5. All right? And the last thing is that since it's exponential decay, since it's a fractional base, it's going to go steep. Whoa, this is so hard to draw on. Okay, it's going to go steep, cross there, and flatten out. Okay? Exponential decay. All right. So one more of these. All right. H of x equals 3 times e to the x plus 1. Okay. Well, that e to the x, remember the estimation for e is like 2.71-ish. Okay. So if it's 2.71-ish, that's just going to be regular exponential growth. All right. So that's not going to mean anything. That plus 1 means that we're going to go up 1. Okay, that times 3 is a vertical stretch of 3. All right, it's a vertical stretch of 3. So if we look at what that's going to look like, we are moving up 1, so our asymptote goes up 1. Okay, that vertical stretch of 3 means that we are going to have to go, instead of just 1 step up, we're going to have to go 3 steps up from our asymptote. Okay, so normally this point would be 1 step above it, but this is going to go 1, 2, 3 steps above it. So then it's kind of flat and goes zoop. All right. All right, so there's exponentials. Logarithms are very similar, okay, except for on a logarithm, you're going to have a vertical asymptote on the y-axis, and now the point is going to go through 1, 0. Okay, it's the exact opposite of exponentials, which makes sense because we know that they are inverses. Okay, the logarithm graph starts out steep and then kind of flattens out. Okay. All right. So logarithmic functions have a vertical asymptote at x equals 0 and go through the point 1, 0, unless it moves around. Okay. So let's look at some examples of that. All right, log base 2 of x minus 3 plus 1. All right, our base, again, just like it does with exponentials, changes the steepness of our graph, but again, we're not going to really care what that looks like, okay? We're just going for a general shape. So, if I have log base 2 of x minus 3 plus 1, we know that that's going to go to the right 3 and up 1. Okay, right 3, up 1. So that vertical asymptote is not going to get affected by the up 1, but it will get affected by the right 3. So now here's our vertical asymptote. Okay. Now we're going right 3 and up 1. So this point that's normally at 1, 0 is going to go to the right 1, 2, 3, and then up 1. So we're right here. Okay. So here's our graph. Next one. This one says negative log base 4 of x plus 2. Okay. Well, that negative is going to be an x flip, as hopefully we know because we've done it a billion times this year. And then we're going to go left 3. I'm sorry, left 2. All right. So that left 2 will affect the vertical asymptote. All right. And by x flip, I mean that instead of increasing, this thing's going to be decreasing. So this left 2 means our point's right here because it moves from 1 to -1, just 2 spots. And because of that x flip, it's flipping over the x-axis, so this thing looks like this. Okay. All right. Last one. So this is going to have a y flip. And it's going to go down 3. Okay. So going down 3 does not affect a vertical asymptote. It's already infinitely up and down, so it's staying right there. All right. So this point's normally at 1, but it's got to go down 1, 2, 3. And then there's a y flip, so it's on this side. So our graph runs along here,